Okay, here we are. I just wanted to go ahead and record some notes. Um, we are doing some warm-ups here. Um, we are working with simplifying polynomials, and polynomials means there's multiple terms in the expression. And the first one is, well, all of these will be using the distributive property. And the first one here, we have a outside the parentheses. That means we're going to multiply to each term on the inside, and I encourage you to highlight that second term within the parentheses. So when we have a times 3a, that's going to give us 3a squared, because we're taking a times a, and we can rewrite it as a squared. When we have a times a, that's equivalent to a squared. I'll go ahead and share that. That's the same thing when we have the area of a circle. So when we worked with radius squared, we talked about the radius square is equivalent to r times r. So whenever you see a variable times itself, it's going to be equivalent to that variable squared to the second power. And so here we have 3a squared, and then we have a times positive 7. So that means we're going to have a positive 7a. On the second warm-up, we have negative 2, and that's going to be distributed to each term. So here we have positive 6m, and then here we have negative 1. So negative 2 times m squared, and the m squared has an invisible 1 in front. So negative 2 times 1 is negative 2, and then we attach the m squared. Negative 2 times positive 6m, so that would be a negative 12m. Negative 2 times negative 1, negative times the negative, that's our positive, and then 2 times 1 is 2. All right, here we have positive 4 and distributing to each term and in the parentheses. And the second term here is negative 2y. So we take 4 times x squared, 1x squared. So that's 4x squared. And then 4 times negative 2y, that's negative 8y. All right, what is a factor? It is when we rewrite an expression as a product of factors. So what does that mean? So we have an expression. We have 4a plus 8. So that's a simplest form expression. We want to go ahead and see if we can provide a factored form of this. So that means we can take this expression and factor out the greatest common factor. So 4 and 8, they both share a greatest common factor. The greatest common factor between 4 and 8 is 4. So we're going to pull it out of each of these terms. So 4, and then we use the parentheses, and then 4 divided by 4 is 1a, because a is not shared amongst both terms. And then positive 8 divided by 4 gives us positive 2. So we were able to provide a product of 4 and 1a plus 2. Then when you multiply it together, you get your simplest form. Okay, sometimes though, when you get an expression, we have a set of polynomials, which are multiple terms within an expression. That's what a polynomial is. That cannot be factored. So you cannot pull out. So each terms in the expression do not share a greatest common factor. Well, when that occurs, that means we can call it a prime. So there are several factoring methods. The approach depends on the polynomial, which again, polynomial means multiple terms in an expression. we will start by identifying and factoring out the greatest common factor, GCF. So steps for factoring a greatest common factor. We have step 1, identify the greatest common factor of the polynomial. So you're going to check the coefficients. What is a coefficient? Well, the coefficient is, so we have 4a here. The coefficient is the number in front of the variable. That's our coefficient. And variable, well, this is our variable, the letter, the unknown. The variable must be present in all terms to be greatest common factor. If a variable is present in all terms, you take one of the smallest exponents. We won't get too much into that, but just to be aware that that does occur where you do have common variables in terms, you can factor it out. Step number 2, you're going to divide each term by the greatest common factor and leave the remaining factors in the parentheses. So you're going to have the set of parentheses, and the parentheses is the values that are left over from dividing the greatest common factor. And then check your work. You want to check if you can go ahead and take the factored and multiply it back into doing the distributive property back into the simplest form. If you get the original answer, you correctly factored out the value. All right, so let's check this out. So some examples. Let's go ahead and look at these expressions and factor each polynomial. You can check your work by distributing. If a polynomial cannot be factored, write prime. So number 1, we have 3x plus 12 terms. So we can pull out a 3, and that leaves us an x plus 4. Number 2, 7 is our greatest factor. And then 8m plus 36n. We have a common factor of 4 is our greatest common factor. And then greatest common factor is 5.